Yeah, hello all. A very good evening to all the faculties present here. So welcome you all once again for day 3, training for data analytics with IBM Cognos. So I request to all the faculties to please call to colleague faculties to join the session immediately, because we are going to be start today's session at 6:05. So I request to Mr. Saurabh sir, please tell to the faculties to join the session immediately. So we'll wait for 5 more minutes and then we will start with the session. Thank you, dear participants. Yeah, thanks to all the faculties to join the session. Now I request to Mr. Mohan sir to please give the new topic today, that is exploratory data analysis. So now I request Mohan sir to start with the session. Over to you, Mohan sir.
Yeah. Thank you, Shivam. Well, good evening, everyone. Welcome to day 3 on the faculty development program on data analytics with IBM Cognos. Am I audible, Shivam? Participants, can you hear me clearly?
Yes, you are audible, sir.
I just shared the technical presentation with you all. Hope you all can see that. So we would now in day 3, after certain exposure to business intelligence and data analytics and types of data analytics on day 1, and have an in-depth know-how about Cognos Analytics Business Intelligence Platform, its rich features, application functionalities that we could discover yesterday. With that exposure, we would now try to move towards an experience on how to actually utilize this wonderful BI web-based business intelligence platform of IBM's Cognos Analytics in 2 phases. The agenda is divided into 2 major applications. One is exploratory data analysis initially, which is the first step of the methodical framework of data analytics. The second would be on data pre-processing, which is the intermediate step in BI or data analytics. 2 of these opportunities would be presented to all our participants on day 3 in this evening session. Once again, welcome everybody to day 3 of the faculty development program. So we'll start with our first point and theme, exploratory data analysis, shortly EDA. While data analytics essentially provides the opportunity for the data enthusiasts or researchers to investigate the opportunities of exploring or investigating inherent relationships among business process data, while visualizing and also taking forward the knowledge insights and put forward them for data or predictive modeling. Before one achieves the art of modeling with data, very foundation steps or the initial stepping stones are a rigor or more in-depth investigation of the data. Such an activity is called the exploration of the data, or more typically exploratory data analysis. So what happens in data exploration? What we should do in order to explore the data? Let's first understand what actually data exploration is. Data exploration would allow the data enthusiast or researcher or data investigator to perform an examination of data in order to study or examine the inherent or invisible or hidden inside trends that lie usually deep buried inside the data. So you can consider that this as the most critical step in the data analytics framework, because the more the researcher or the learner would spend sufficient amount of time in exploring the data, the better are the relationships that can be explored and exploited. Then how to conduct data exploration and how to benefit out or take an advantage of it. Usually there are many methods that researchers might understand and implement. The foundational tools include application of statistical methods, statistical data exploration and analysis techniques that range from simple measures of central tendency to dispersion, etc. Today, on top of the basic statistical methods and techniques, data exploration with Cognos provides us the opportunity to apply the required analytical practices and approaches also. One of the most preferred method for data exploration that is globally accepted and seems to be very user-friendly is pictorially presenting the data. That is the translation of raw data into visual representation formats, because from the language of computing, cognitive computing, human brain has the perception to understand or grasp the essence of complex environments such as data environments when they are structurally formatted and translated into easily interpretable visualizations. That's why data visualization also becomes a subsidiary of data exploration. But in this exercise, we would like to apply the exploration of data through basic statistical techniques combined with more insight generation by suitable and proper visualizations. Now, before we proceed for exploring data, let us have some initial understanding about why we need to explore the data as a layman. Raw data usually which gets generated from business processes, like if you recall the business intelligence architecture once again, there are different sources of data that are actually behind the scene for data generation and management. Whatever is the source of the data, whatever is the data container, all these data becomes continuously a challenge for the organization in terms of storage and processing. The usual characteristics of data that makes it more complex for organizations is by its volume, that is size. Voluminous data generates from internal, external, and other tertiary sources like technology. The nature of the data that it originates, because most of the data might have its own formats, typically like numeric in nature, non-numeric in nature, or graphical images, or other streaming video related data. Whatever is the type and format, the variety also poses a typical challenge to the observer or data analyst in order to model the data effectively. By time and space, data also generates or gets created by greater speeds at greater velocities. Besides these three essential challenges or characteristics, the most important one is data exhibits the biasedness or uncertainty with it. Typically, this characteristic is called the veracity. All these four V's essentially retransform the data in the current scenario as the big data. Thus, it becomes now the necessity or the need for observers to explore those big data through proper analytical framework. If such data can be put forward for a methodical exploration, proper visualizations, and modeled using certain computer-based software are put forward for analysis using computer algorithms, definitely or unarguably, valuable insights could be extracted from within the data. So who performs data exploration in the real world? In an industrial research, typically, players like data analysts, data scientists, or other information researchers, or from the academic learning environments, all the enthusiastic learners, the teachers, the student, the practitioners, the philosophers, all can conduct this kind of exploratory data analysis. The objective of conducting exploratory data analysis, once again, is to contribute to generating useful insights that otherwise would help the business managers or the people who dependent on data-driven decision making to conduct or to result in a very efficient and effective decision making process. It's all the art and science of examining or investigating the inherent data patterns within. How to conduct data exploration? While there are a plethora of methods to conduct data exploration, to start with, all lies within the data. That's why keeping the data point in view before we aim for a higher level application of analytics, like whether you do a descriptive or diagnostic analytics, are we targeting our research project to build a predictive model for our problem statement, or we're trying to offer a prescriptive model for the problem under study. Whatever is the objective, there is certain necessary and required steps to be performed in EDA, which includes first understanding each and every piece of data item. If you recall the data analysis life cycle, where the journey of organizations would begin from raw data collection to data understanding to data preparation, followed by visualizations and analysis, and finally concluding at generation of insights. To implement this life cycle, we need to go through this methodical approach. First, the users need to understand what are the parameters or features or variables that are presented in the data set related to a problem statement. The user or the Cognos analyst should have an in-depth understanding of each type of the parameter and its associated values that are available or obtained from the research study. Then proceed to examining each and every piece of data item through a statistical method called the univariate analysis. As the name says, in this process, the observer would focus on understanding the characteristics of the data, such as studying the distribution of a numeric data item. Typically, a numeric data item could be considered as a continuous variable, or exploring the distribution of a non-numeric data item, typically a categorical data item. So by focusing our efforts on exploring each individual piece of data will allow us to gain some basic patterns or insights about each data parameter in the data set. If you want to explore more complex relationships or try to derive better insights from the data that add more value and meaning to our research objectives or problem, we can further proceed from univariate analysis to bivariate analysis. As the name says, bivariate analysis is a technique where the observer would try to study the relationship between two variables at a time. These two variables could be continuous, categorical each, or a combination of continuous and categorical also. While the first three steps essentially are the building blocks of data exploration, an opportunity for researcher to gain more exposure on data characteristics is coupled with a bit of data pre-processing. Raw data undoubtedly has millions of insights associated, but while exploring, the observer might come across certain challenges unidentified until data are explored. These unidentified challenges or unexpected challenges might include sometimes some data are absent or not recorded in the data set. There are several reasons why data might be absent or not available. That there are plenty of reasons, but whatever might be the reason, the data seems to be missing in the data set. So a special kind of treatment can also be offered under the data exploration and pre-processing phase in analytics framework in order to make sure the data are meaningful. Alongside with the challenge of missing values, there also lies certain unidentified anomalies, typically the outliers. Outliers are those data characteristics that found to lie abnormally distributed from the normal range of the data. For example, the price of a product or a commodity might seem to be typically higher than usual in the market on a certain day, while the price of the same product other than that day would fall in a regular range. So one can understand that the price of that commodity, why it has witnessed a huge increase in price, can be considered as a special category of exploration under outlier treatment. Apart from this, the data explorer could also try to transform the data as and when required for computation and analysis. Usually, computer algorithms are more flexible and agile in crunching numeric data, but raw data is a heterogeneous combination of numeric and non-numeric, that is text-based values also. That's why to apply basic statistical techniques or visual practices, data must be transformed into a suitable format, which is easier to understand. Besides all these steps, sometimes we need to do value-added analysis or exploration by additionally creating data from the available data itself. Typically, such a type of items could be called as calculated fields or calculated parameters in order to better explore. So this is a very generic methodical framework in order to conduct data exploration using any kind of analytics platform, including our Cognos analytics from the IBM. First, what is variable identification? How can a user understand type of a variable? Consider a user is trying to examine a realistic real-world data collection where there are distribution of data by different features. A student in a classroom can have certain characteristics like gender, ID or roll number, could have attended an exam and scored certain marks, carry some physical characteristics, body characteristics like height and weight, and might also add more value by playing a sport like cricket. If you have this basic data characteristics associated problem and you are interested to determine which type of gender, which type of student of which gender and having what demographic characteristics might show a tendency to play a sport or not. If that is the objective of your research, to begin your exploration, you need to segment your data characteristics as what are the different type of variables we have, what is the data type of each of these variables or features or parameters, and what is the target or objective in order to explore the data. For instance, we can call the gender of a student, the height, weight characteristics as the influencer variables or explanatory variables. Typically, in a simple language, we can call those as inputs to the business problem. Whether given at hand these explanatory variables, how are they going to affect a target variable, where in our case, a target is to assess whether a student would show some interest in playing a sport like cricket or not. Typically, gender variable is a categorical, that is non-numeric, spreading into values like male and female. While height and weight might be numeric values in real world, might have certain distribution associated with. That's why the essence of EDA gives more opportunity for the explorer or researcher to examine each and every feature in the data problem to its extent. Thus, by examining the category, the data type, one could get basic understanding of data in detail. Then, how does analytics begin with? Without any doubt, the early era of analysis, where the core of analytics lie, it all starts with application of statistical tools and techniques. In statistics, we have the fundamental techniques which play a vital role in most of the research problem management. One such area of the foundation statistics is where we come across with our experiences and measures of central tendency. Central tendency being a critical element in summary statistics that would allow an observer to gain an in-depth summary descriptions of the raw data. Three measures of central tendency are widely preferred in statistical techniques, namely the mean, the median, and the mode. While mean, median, mode are the basic fundamental instruments of statistical analysis for any research, value added measures from analytics also can be coupled with these basics. Now, how can we conduct univariate analysis? Let us see. As the name says, in univariate, we would like to explore the variables one after the other. But where to begin? You can start with a random parameter in the data set that otherwise or ad hoc selection, and then start exploring variables one after the other. This is a time consuming process, but of course is very required in order to have a deeper insight about your data problem. While exploring, the researcher might encounter whether chosen variable or chosen parameter might also have certain unidentified challenges like presence of missing values or anomalies or outliers associated with the data item. So in univariate, we need to discover characteristics of the data item as well as challenges associated with data item. For a continuous variable like numeric in nature, example, age of individual, height, weight, cholesterol level, blood pressure, marks scored by a student, yearly income of an individual. For such a type of real world entities, typically measures of central tendency, that is the application of mean, median, mode, really give a foundation to univariate analysis. If one would like to also know more about the spread or distribution of a continuous variable through univariate analysis, an alternative method is to go for data visualization. Preferred visualization tools for a univariate analysis technique include histogram or frequency histogram and box plot or box whisker plot. We shall apply all these visualizations on a simple real world problem by doing rigor hands-on in this evening session on in this day 3 FDP. So here you can see how different central tendency measures are measures of dispersion. There are also statistical techniques like measures of dispersion such as range, variance, standard deviation, skewness and kurtosis and others. All these add more value by in-depth examination of the spread of the data. While statistical techniques are on one side of the univariate analysis, data visualization methods also add richness, enrichment to univariate. Preferable tools for univariate, again I'm repeating, you can use a histogram for studying the spread or distribution of a numeric continuous variable, or alternatively you can go for a box plot. I would elaborate more on box plot in the coming slides. Coming to bivariate analysis. Raw data certainly has inherent associations among them, or raw data typically exhibits strong or weak correlations among each other. Typically, the continuous variables inherently, independently have their own correlations, or might also have certain correlation with our target variable. In analytics, we call these input variables as explanatory variables or predictors, and our target variable can also be called the response variable or the outcome of a business process. Bivariate analysis goes one step ahead than univariate by trying to model the relationship or exploiting the inherent relationships between categorical variables, continuous variables, or a combination of categorical and continuous. The major objective of doing bivariate analysis is to derive any kind of specific pattern such that if two variables depict any linear or non-linear relationship, the relationship can be measured using the statistical measures like correlation and covariance that would measure the magnitude and direction of the relationship, how two quantities are associated inherently. Why we do bivariate is, apart from univariate, we are able to study the causal effect or the combined effect of two parameters over a business outcome. In univariate, we would like to model each variable, and bivariate, we will also examine the inherent dependencies or correlations among data. Thus, uni and bivariate analysis enables the data analyst to figure out the most critical predictors that would otherwise are impacting the business outcome. Now here, for our understanding, I would like to present a case study or business use case participants titled Assessing or Analyzing the Impact of Demographic Parameters on Sales Performance of a Business Firm. So what is this use case and case study? Let's go in detail. A business organization is selling some product and generating some sale value by operating in 3 different geographies, namely Hyderabad, Bangalore, and Mumbai, for instance, the scenarios. The firm wants to understand whether sales are being impacted or influenced by certain demographic parameters. We would, of course, elaborate what are those demographics from the data set. Our objective is we would take this opportunity using Cognos analytics and understand and explore and analyze by doing all the discussions, univariate, bivariate, statistical analysis and visualizations to determine how are the given set of input features, how are they going to have a causal effect on the target, which is the sales of the business process. So to achieve this research objective, the firm would recommend an analytical approach. So thus, using the Cognos analytics platform, we need to carry out 2 important activities. One is exploration of the data added with value-added data visualizations. But where to begin with? Always analytical experiments or analytical research must always start with having a deeper understanding of the data itself. Given the data set contains several features or variables or predictors, such as sales executive is the first column, as you can see, and name of the salesperson, gender of the salesperson, age of the salesperson in years, location in which the salesperson was operating the business, and the target variable, which is sales in rupees. This is the data set that was shared to you all the participants yesterday, which we could upload into our Cognos DB yesterday, sales.csv, if you all recall. Have a quick look at this snapshot of the data on screen, participants, and try to answer my questions. After looking at the data, could you figure out why we need to put forward this data for analytical modeling or analytical approach? With what objective shall we take this data forward for analytical data exploration? What are the key parameters or key outcomes or insights that we could extract from data? Anybody? Please type your answers in the chat. This session requires today a very high interaction, participants. So please be highly interactive today. You can involve yourself in the exploratory data analysis. The last column, if you see the sales in rupees, as you all can see that it is a numeric column target. Now, if you would like to start my exploration with a question in mind, do you think the sales value generated by each salesperson? Of course, there are 20 salespersons, as you can see in the data set. The number of observations records equal to 20. Now, I'd like to start the EDA research. What parameters given in the data set do you think might have an impact on sales? Thus, the demographic parameters in the given problem statement are gender, age, location. While if you see the first column, sales executive, carefully, it looks like as if it is a unique data item, right? Because each salesperson has a unique employee ID. So we need not worry about the unique values inclusion in our analysis. We can exclude it. Name of the salesperson, do you think might have any connection to the sales in rupees? Typically may not be, so we can rule it. Correct. You are right, Sharadji. Now let's start building our research hypothesis around our demographic variables, which are gender, age, and location. Correct. Gender. How many of you think gender might have an impact on sales? These are all hypothesis, is nothing but our initial assumption or presupposition about that. Correct. Zobji says may not be too much. It may not be too much until we go deep inside the patterns and discover what actually the connections are. But at the outset, let's start with a hypothesis that gender is not significantly affecting sales. Gender might not significantly. So for a research problem, hypothesis can be two types: null hypothesis and alternate hypothesis. So the null hypothesis is there is no significant relationship between gender and sales, while an alternate hypothesis can be gender can affect sales, but which one is correct? We can only answer the question after we complete a rigor EDA on this problem statement. Priyaji says age can affect sales. Priyaji, can you elaborate more? Like how can age affect sales? Shivam, permit the participants to unmute themselves if somebody would like to speak to me, because this requires high interaction today.
Sure, sir. Now give the permission.
Yeah.
Yeah, difficulties. Now you can unmute us.
Correct. Anybody would like to add to your speech on? You are most welcome. Somebody whose age is higher might have more experience. Correct.
One observation.
Yeah.
That I was looking at the city, like for demographic, I was looking at the city that whether Bangalore is having less sales or not. So I looked at the row number 3 and 4.
Okay.
So then I observed that a person who is of 27 years of age, he sold more as compared to Vijay. So I was comparing Vijay and Ramesh.
Very good. Nice. See, every one of us might look at the same data, but every one of us might ideate and think in a different way. While some believe the gender might have a minimal effect, while some of us might opine age might have certain correlation with sales, while some of us might also confine our thought to region being one of the prominent variable. But if you start your exploration from the sales, you're right, Mamataji, age and city also. Sales, always when we look at our target variable, our human psychology suggests that what is the best one to explore. Given the target variable as said by one of our participants, the maximum sale value is what has discovered. Imagine the sales given are in thousands. The sales nomenclature is in thousands. So 77,000 is achieved at which location, ladies and gentlemen? Please see that. 77 is a maximum value that I could find from my observation here. It belongs to Bangalore. Thank you, Zaibji, again. Fantastic. Nice.
Bangalore.
Yes, Ria, everybody. I request all the participants to kindly be active on the chat window and ping your answers to my questions for better interaction. And such a Bangalore location generated by which gender? You're right, Shalini, great. Which gender? Fantastic, Joabji, again. Thanks for your very quick answers. Yeah, good. Male gender. Ritika ji also. Good, great going, ladies and gentlemen. Male gender. So there is a male salesperson operating at Bangalore and could generate a highest sale yield 77. And the name, of course, the name is something XYZ here. Then let's focus on the age also, right? That age of the salesperson is around 27 years. Very good. 27 years. But how could we connect the dots? Like how each feature might have this thing. Likewise, can you discover what is the minimum sale value generated by the group of salesperson in the given data set? Zabji again says 11K, right? Good. 11K, I hope, right? Sarvji also adds the fact correctly. Very good. Great going, participants. 11K is the minimum sale discovered by our participants. Again, it belongs to which location, city? Surprisingly, the minimum sale also comes from the Bangalore region. Great. And which gender generated that? Again, if you focus on the gender demographics, it is male. So from this fact, we could make some basic understanding about our data that both maxima and minima sales are generated at Bangalore region by male gender. Then what is the out of box thinking in it? Female salesperson neither generated maximum sale nor generated the minimum sale. This is the value added thinking out of the insight that we could discover. Then age, as we discovered, the maximum sale generated person's age is 27 years. Minimum sale generated person is 20 years. Correct. Now, could you help me, participants, in finding what is the maximum age of any salesperson in the given data? Please discover the maximum age of any salesperson. Riyaji says 29, Zabji says 30. Okay, right. I think, is it 30? Great. Most people are answering 30. Thank you. Thanks a ton. 30 years is the maximum sale of the salesperson whose gender is female. Right, great. Similarly, please find out the minimum sales person's age of the salesperson who has got the minimum age in years. Ritika ji says 20, and while there are some multiple answers coming up, good observations, great. While now I could find a number 19 also popping up in my chat, great. 19 years, which is female. Thank you, everybody. Yes. So both are female, right? The eldest salesperson is a female, younger salesperson is also female, 19 and 30. But if you see, did the eldest salesperson who ages 30 maxima did generate maximum sale? What is the sale value by the eldest salesperson who is 30 years age, working in Mumbai location? You're right, Mamataji, everybody. 31,000. Thank you, Shivani ji, everybody. 31, great. Similarly, the youngest salesperson working at Bangalore location, aged 19 years. What is the contribution to the sale? It is 36. Very good. Nice. Great going. Do you think both these sale values by the eldest salesperson and youngest salesperson are anywhere closer to the maximum sale? What do you say, Zoibji? Vishalji, everybody. Nowhere, right? Nowhere. You're right, Saurabh Sharma ji. Very right. Nowhere the sale contributions by the eldest salesperson or youngest salesperson are closer to the maxima. But are they closer to the minimum sales? Please check it again. Are they closer to the minimum? What is the minimum sale we have? 11. right? So that means what can we discover? How do you assess, if you are the sales manager of this firm, how do you understand the performance of your sales team? Irrespective of gender, irrespective of age, location. That means from the basic investigation of data, we didn't do exploration still. In fact, we just have some top to bottom look of the data, and we could discover some interesting facts in the data stating that. Now, if I ask, do you think gender is affecting sales? Question number one, research hypothesis. Probably. All answers might be probability. Yes, correct. Do you think participants' age of the individual salesperson is driving sales? Probably. Yes. Do you think location in which the company is doing the business might affect sales? Probably. To answer the probability into reality, it is necessary for us to take forward this research problem and to do analytical data exploration and visual analysis and modeling. That's why one should understand the need for data analytics correctly. Not all problems might require to put forward for analytics, but if you want to dig deep inside the data and extract the facts, because raw data, the definition goes is collection of facts. Facts are different from figures, participants. The data which I presented has figures visible to our naked eye, but facts lie deep inside the data. Figures can be analyzed, facts can only be explored and extracted. Do you agree with me? Hence, to extract the real facts inside the data, we are supposed to do the exploratory data analysis. Is it clear? Right. Now, how to proceed forward on the problem statement? Let's go one more step. Now, how to explore? Before we explore, let us build our research objectives or the KPIs, key performance indicators. There are multiple questions or queries that one can compile in order to find interesting answers for the problem. First question might go like this. Is there a relationship between gender and sales such that the authority, the strategic leaders or managers in the sales in the firm can decide based on the relationship explored between gender and sales, they might make some crucial decision in the future, which gender to hire for sales performance improvement in the future. That is one critical decision that they could make based on the data-driven pattern between gender and sales. Typically, another question might be, is there an inherent correlation between sales value and age of the individual? Of course, we discovered a lot, so we may say yes. How can the future decision of hiring can be related to age? Is it younger aged individual driving sales? Is it elder age individual driving the sales, or is it middle aged salesperson? Which of the age categories are prospective to be hired for better sales progression can also be a better opportunity? You're right, Mamataji. In this scenario, it can be a middle aged salesperson as the data speaks the truth correctly. Then, does location matter for increasing the sale value? We already debated. There are 3 locations, Hyderabad, Bangalore, and Mumbai. How does location affect the impact on sale value? Thus, there are a plethora of opportunities for us today to discover the data artifacts and generate valuable insights from this. All these questions can be addressed by conducting rigor data analytics. But if you once again look at the data, let me take you all back to the data again. As I said, how your data analytical framework should start? Identifying the data items or understanding the variables. Could anybody tell me from the given snapshot, how many types of data are present in the problem? I mean, do you have numeric and other characteristics data? If so, which are continuous data? Which variables represent numeric or continuous? Yes, you're right, Zavji. Number and string, correct. What demographic variables fit into continuous data? Continuous means numeric. Saurabhji, the question is about continuous data. Sales, you're right. Ayushji answers correctly. Age and sales. Age is one variable, which is numeric in nature. Sales is another variable, which is also numeric in nature. You're right, Ranuji and Sharadji also. Likewise, participants, can you tell me what variables in the data are non-numeric, that is categorical in nature? Check the data and try to answer the question. categorical in nature. Location, name of the salesperson, gender of the salesperson are all categorical. But we also discussed that name being a tentative or least significant or otherwise not a useful variable, we could tentatively exclude that variable from our analysis. That's why we could focus our efforts on location and gender. Deepesh ji says the location and gender can be considered. Correct. Shivani Singh ji also says gender and location. Given these understanding of the data, you can now proceed to conducting the real analytics with exploring the variables by type, that is univariate analysis. For continuous variables, that is age and sales, we can apply measures of central tendency. We can apply measures of dispersion also. So mean, median, mode, standard deviation, variance, which are all very basics, can all be applied. If you recall the initial slides, what type of visualizations can we use in our project to conduct univariate analysis for continuous variables? That is for exploring and visualizing age and sales. Yes, you're right, Zarji. Histogram and box plots, I recommend. Histograms and box plots are well used to study the distribution of a numeric variable in detail. Then bar chart can preferably be used as a fundamental data visualization for studying the categorical variables flow or categorical variable distribution. Other than bar chart, we have a bunch of charts. So I'm just skipping on the basics of statistics, keeping in view of the knowledge most of the participants have in research, like what is mean, median, mode, standard deviation. Rather, I would emphasize my discussion on data visualizations, keeping the time and space. Data visualizations add more life to exploration. Cognos analytics, like as other analytics tools in market like Excel, Python, R, and Tableau or BI, has a bunch of rich stack of visual schemes for conducting exploration. To name a few, you can start with histogram, bar chart, line chart, scatter plot, box plot. Permit me, participants, to give you the right knowledge transfer on what kind of graph should be used for what type of data, like the one which I was trying to present in the last sessions with you all. Essentially, there are two types of data in research problem modeling: quantitative data and qualitative data. If you are working on qualitative data that doesn't exhibit a distribution like a numeric, then your preferred choice of measurement can be bar graph, correct, or column when you are trying to study the distribution of a numeric over a categorical quantity. Pie chart and line chart. These are all the different elements that a researcher can put into action for exploring qualitative data characteristics. Similarly, if you want to deal with a bar chart, when should you use a bar chart? A quick note for all the participants for your benefit. If you want to display the frequency distribution of a quantity, frequency distribution is you would like to study how many male salesperson, how many female salesperson are working for our firm. You can explore that pattern by presenting the distribution of the gender through a bar chart. Similarly, if you like to study the distribution of sales by location, for instance, how are the sales distributed over location? We have currently 3 locations for our problem statement, that is Hyderabad, Bangalore, and Mumbai. You like to explore how are the sales distributed location, you can display it as a bar chart. A near alternative of a bar chart can be a column chart also. Column is a vertical representation of the quantities, while bar can be a horizontal representation of the quantities. In the line, we also have to understand another important tool for data visualization for exploring our data better, called the pie chart. When should one use a pie chart? The pie chart can also display frequency distribution like as bar chart, but the key difference between pie chart and bar chart is if the researcher would like to model the data quantities or represent composition or propositions of data to the total data as a whole, or display the ratio of the observations in relation to the whole of the data, then we can go for the pie chart. Pie chart doesn't have any coordinate axis, unlike the bar which has x-axis and y-axis in the mathematical coordinate system. Correct. So one should have a clear vision about what visual element should be used for what data so that we can better explore the patterns correctly. Then line chart. Sometimes in our data, along with the demographic variables, certain value added parameters such as date and time related parameters might also are reflected. Especially in such scenarios, the researcher or analytical observer might take an advantage of modeling the data over time parameter in order to explore or depict the trend that lies within the data. For instance, a sales data analyst is trying to discover the progression of sales in a 12-month sales calendar. So here, each month represents a time parameter, that is frequency distributed by monthly sales, can better be illustrated using a line chart. Thus, line charts are mandatory when the user would like to explore the data points to be studied in relation to the time. Good question. When data has too much fluctuation, right? 260 and 4, yes, correct. If you want to see the cyclicity, seasonality, irregularity, if you want to study Zohebji and other participants, if you would like to study these irregular, seasonal, and cyclic trend-like characteristics, preferred chart would be a line chart or a much model robust time series chart for your visual analysis. Because whenever we are dealing with numeric continuous data, the variance, standard deviation in the data becomes a typical challenge for the modeler to understand the current patterns and focus on the future prediction. Likewise, the list goes hitting on. But when we talk about quantitative data, like specifically the understanding the dispersion distribution of the numeric, we can experiment again with a stack of visualizations, starting from a frequency polygon or a frequency histogram or a cumulative frequency curve, that is Ogaev curve, or a box plot. There are more in the list to come, but widely used visualizations I am just presenting here in this session. Right, this is an Ogaev chart, which can be like a cumulative curve, which can help us. Yes, Saurabh, Cognos also supports scatter plot also, you're right. There are many type of visualizations that we can use in our exploration. Ogaev chart particularly useful if you would like to study the pattern by estimating whether a group of data points lie above or below a threshold. A threshold is a benchmark like an average or a median, and you would like to see how closer are the data spread around the threshold. You can plot them in an Ogaev chart or box plot also. So given these basics, I would be commenting on box plot parallelly with my practicals. Now I request all the participants to connect to your Cognos analytics platform. Let's log into our Cognos and start conducting our initial EDA in this exercise. So could you all see my browser screen, participants? Please confirm. Yes, if you have logged in, that's great already. So permit me to log in here. I'll be logging in my registered credentials that I have received. Let me redirect to my Cognos analytics platform from my profile page. Yesterday, we have uploaded two data sets for information. One is sales.csv, the one which use case we discussed in the presentation as case study. Second one is the bike buyer. Once you get a go through of utilization of the platform on one data set, the remaining can be used as a practice sessions for perfection. Let me launch my web-based BI Cognos analytics tool. Now we would take the opportunity now with this hands-on session to go in detailed explanation on application of different visualizations. So as you know, for our yesterday's discussion in Cognos analytics know-how session, we can upload data of different formats, and by default all uploaded data are present in the content folder. So all participants, please follow the on-screen instruction carefully, slowly, and operate on your machines. Navigate to your My Content folder and make sure whether you have the data set for our current problem, that is sales.csv, uploaded or not. Yesterday, we could already upload. If any other participant who could not upload, please try to upload the data set on your Cognos account. You already know, you can just go to the resources menu and choose upload, browse for your file and complete the upload operation. Once the upload process is completed, now we can proceed to conduct data exploration. There are multiple ways to do this. One is, once you have the asset loaded, data set loaded onto your system in the platform, you can directly go to the action menu or more options, click on the more options, and in the pop-up menu, you can see the first option available, create exploration. I repeat, to start your EDA, locate your data object or asset, click on it or right click on it, anything, right click also will give the menu to you, create exploration. That is one way. The other way is, you can go to the open menu on home and click on the new menu command and then choose exploration. Under explore section, you can choose exploration. Either way, both will redirect to the EDA pages. Either way you can do. First method is, we will try to use the object and directly proceed to the exploration. Request all the participants to go ahead with the on-screen instruction, create exploration. Now we are redirecting to the exploration page. Please confirm, participant, those are doing hands-on. Are you also in the same page that I'm in? Could you create exploration? Thanks, Setan, everybody, for your quick response. Great. Now, select a starting point. A EDA on Cognos is a great journey, believe me, because the capability of Cognos Analytics platform being chosen for this exercise, because it is highly AI powered, artificial intelligence powered, programmed tool. That's why if you see, some suggestions are coming. The tool is recommending us, try starting with one of these measures and metrics. So the recommended metric for our problem that we are going to study is typically our target variable. What is the target variable, participants? Recall, sales in rupees, right? This is sales in rupees. Now Cognos is saying, are you interested, user, to explore this variable sales in rupees? Of course we are interested here. So in order to start our exploration, start by clicking on your target, that is the recommended metric. Click sales in rupees, everybody, and you will get something on your screen called the relationship diagram. In Cognos Analytics, you can type anything, Zoebji. Other than the target variable or tool recommended metric, you can also type any other attribute that you are interested to explore. You can do that in your search box here. You can type the search name and get your exploration started. But typically, because our research problem hypothesis objective are more connected to our target, that is sales, we are now focusing on sales. So have you all got the relationship diagram here? When we clicked on the sales in rupees metric, Cognos is presenting us with the relationship diagram. At the core of this relationship diagram center is our target variable sales in rupees, and you could see the relationships that Cognos could analyze behind the scene, how age is affecting sales, gender is affecting connected. These are the connections. If you could carefully observe in this relationship diagram, could anybody observe the thickness of the lines correctly? Are all the relationships strength equal or they varying? The thickness of the line from each predictor to the target could clearly be seen here. Some of the relations are very thick and some are thin in nature. Yes, they are not equal. You're right, Ritika ji. For example, the relationship between age and sales was understood by Cognos Analytics algorithm or tool is to be very less than 15% of the sale values in the data set are found to be influenced by the age variable. This is all the tool's capability, but we cannot just go with this relationship diagram. We should derive more insights to believe in this relationship diagram further too. But if you see the thickness of the relationship diagram from location to sales, location contributes to 39% significance in driving sales. Similarly, gender adds to 30% significant impact on driving sales. This is how the analytical tool could draw the patterns on our target variable. If you want, you can click on edit diagram and also choose secondary relationships. But this option is useful if and only if you have more parameters and more data volume in the data set. I repeat, when can we edit a diagram and choose secondary relationships? Secondary relationships are more internally hidden relationships that otherwise are not presented in the high level view of the relationship diagram. Even if I choose edit diagram and choose my secondary relationships, still the patterns doesn't change. Secondary relationships are inherent, which are not directly available on the relationship diagram, but that works well when the volume and variety of data that you're dealing are typically higher. With secondary relationships also, the pattern clearly tells us fact that we have the similar pattern that location and gender seems to be bit high significant than age. That is the first method to start with the relationship diagram in place. If you would like to move the relationship diagram slider at the bottom where I'm hovering the mouse, you can move the slider. As and when I move the slider, you could see weaker relationships are excluded from the relationship diagram. What does this slider mean? You are moving the slider for higher significance. You are studying the statistical strength of the parameters which are highly associated. So the higher you move, now see how your relationship diagram now transformed into. Earlier, when we would like to study asking the tool, please show the impact of the variables that are in the range of 10% significance to somewhere around 35. So two of the variables, age and gender, are falling in the significance range of 10% to 35%. When I move the slider further forward, see the changes. Now location added to the diagram. If you move further, that is those parameters which show a tendency higher than 33% significance, only the gender here has that 20 to 33%. If I further move higher, keep moving the slider, the patterns keep on changing. Anything above 35%, if you see, anything above 35 or above that, only location variable seems to be the most significant predictor or much strength associated. So that is how the inside patterns of the data can initially be understood from the relationship diagram. This could be quite surprising for beginners like us, like how are these modeled? Why should I believe these patterns? Of course, it is an IT tool which is programmed in the backend. Is it trustable, believable? If so, let us take an opportunity to discover those realities by conducting data visualizations to determine whether the relationship diagram offered by Cognos is trustable or not, right? Hope everybody is clear till here, right? Great. Yes. Now, there is another yet beautiful opportunity in Cognos, normally in a database management system, where most of us would have the hands-on experience or exposure to writing relational queries. But unlike in a RDBMS, where most of the queries are highly syntactic and semantic in nature, without knowing the grammar of the queries, we could not drill down the data. Contrary to this, Cognos Analytics simplifies the art of querying the data by using a very great intelligent tool called the assistant, Cognos Analytics Assistant. You know, on the top right-hand corner, there is an object placed in your toolbar named the assistant. Where I'm hovering the mouse, try to see the object where I'm hovering the mouse, participants. This is called Cognos Analytics Assistant. This is an AI-powered assistant which would allow the beginners to perform queries on your data to explore patterns, but you need not write any syntactical queries. These look like natural language queries or plain English queries. So if you click on the assistant here, that would pull the assistant dialog box here. That would give us the opportunity to put the dialog box, bring back your relationship to the base state. So put your assistant, and here at the bottom portion of the screen, if you could clearly see, Cognos is asking, are you interested to ask me a question? Ask a question. Could you all get this assistant up and running? How did I get this? Just click on the assistant item here. Then you'll get this dialog box pop up. And here you are supposed to ask a question. Different questions in plain natural English language we can write, and Cognos translates those natural language queries into the actual analytical queries and fires them across the Cognos engine. So for example, I'm interested to see what is the total sales of this company. So I start my keyword with total and see the suggestions offered here. Immediately when I type total, some natural language query suggestions are being offered by our Cognos Analytics assistant. So which one I have to pick? Total sales in rupees. Either you can type it completely or you can alternatively click on it. So this is the another value added benefit for beginners who would like to explore the data using the AI powered Cognos Analytics assistant. I just type total and say total sales in rupees. After typing the query, you can run the query by clicking on this run query button or arrow button. Now the query is running in the background. Cognos displays the total sales. Now you can see here the total sales is compiled. Unlike this environment, if you're working in your DBMS, you need to fire a select query where you need to write an aggregate function participants like sum function. Do you all agree with me? If the same activity was given to us to work in a DBMS environment, we need to write a select query with an aggregate function sum on the column. Without knowing the syntax and semantics, it would otherwise become tedious for the learners. To avoid the complexity of syntax and semantic oriented programming, analytical practices with natural language queries is now gaining a lot of momentum. That's why data analytics is not a rocket engineering, but it's a different engineering to achieve the science behind the data, I say. So the total sales are now generated, that is 871. Further too, you can drill down more insights using this Cognos Analytical Assistant. How we do that? For example, if you're interested in average sales, so simply you can type the average keyword, average sales in rupees. So when you type the plain English word, Cognos understands the natural language of the user and offers some suggestions. So I can choose average sales in rupees as my keyword query and run the query here. This would show us the average sales of the company. Now this is average sales of the total 20 salesperson, that is 43.5K, 55K. Like that, you can also conduct a rigor analysis by further refining the queries or drilling down the data or narrowing down the search. For instance, I would like to see the total sales by gender. So the keywords go like this: total sales in rupees. So make sure when you are trying to do nested queries, you follow the nomenclature. The variable names that are used in the data set should exactly be typed in the Cognos Assistant. If any change comes out, the Cognos Assistant could not identify the column name. It should be reflected as it is in the data set. Total sales in rupees, use the keyword by, by gender. So I may type space gender. So this is quite interesting aspect in Cognos, unlike our syntax based querying. Total sales in rupees by gender. If you could just run the query, this would produce us some data visualization for our understanding, typically a column chart. Now you can see here a typical column chart is produced here, participants. So which gender generated better sales actually? Recall our discussions that we were doing so far. Among the two gender, male and female, which gender produced the maximum sale for the company? I mean, total sales are better. Maximum sale, of course, is by male gender, which is 77K. Minimum sale is also by male gender, 11K. That we could debate in the data itself. But on an overall basis, which gender contributed to total sales volume better? See the data visualization here on screen. You can type your queries in the Cognos Analytics Assistant and discover this visualization. These are all automatically AI powered queries that are running from natural language translation to the query engine. The females drive better sales, total sales than male. Now you could also see a insight is being written by the tool. The greatness of this tool is an insight is being generated, right? The insight also comes up greatly. Yes. So if I just hit the assistant, yes. Female gender exceeds male gender by a volume of 151 units. You could see the graph. The difference in sales volume between female and male is 151 units is the insight generated by the AI assistant. That's why if you would like to do a robust research as part of your academic research, or you're trying to write a research paper, participants, without much difficulty, you could connect your research sample data to Cognos Analytics and discover the art of exploring it in better methods, and also the analytical insight suggestions are also offered for you. So one way is to start with relationship diagram. Other improved way is to use the assistant. But now let's learn the real way of exploring the data in Cognos by discovering the stat and math and visual applications. The third method of exploring the data I am demonstrating here. Because in our presentation, we discovered some methodical framework, univariate, bivariate, as well as trying to discover the probability of data pre-processing are all part and parcel of the analytic activities. So to begin with our journey, the real data exploration, we have the bunch of visualizations which are available for us to include. Currently, we are in the exploration web page or window of Cognos Analytics for information. So you could see here the exploration section we are in, then the data source. If you click on the data source, parameters are available. After creating any visualizations, if you want to pull that visualizations into required outcomes like dashboards, story points, or reports, you can pin each or entire visualization by pinning them. So we'll start with explorations first. You can see on the top toolbar, you have facilities to save your exploration, share your exploration, or also start creating your exploration by visuals. All participants are requested to notice this illustration. Click on create button, participants. You can start by creating a simple single visualization or a comparative complex visualization also. So let us begin our journey with a single visualization by clicking on create. Under select a card. Card is like a display item that shows some important business metric. A metric can be total sales, a metric can be average sales, etc. So click on single visualization, and the tool is asking user, do you want to create a visualization? Yes. If so, you can directly go to the data sources, drag and drop required fields into the canvas. The right side area is called canvas. From the left side, you have the parameters. You can drag and drop. Alternatively, you can choose your required visualization that you are interested in. For example, if I click on this choose a type button, push button, I'll be redirecting to Cognos visual section. How did I get this again? Click on create button, select a card under this choose single visualization, you will get this canvas. Now to do more rigor EDA, click on choose a type. Now, could you notice, participants, different type of visual schemes are now in front of your screen. Cognos is offering you to choose a visualization type. Please check and confirm all the participants who are doing hands-on. Are you on the current screen with me? Yes, thank you, Zaibji, for confirmation. Great. Now, as you recall my presentation in the last sessions, I could categorize all the visualizations into 4 categories: comparison, okay, that distribution of the data, relationships, how a beginner should select a visualization according to the data, nature of the data. I have elaborated in one of my slides in the presentation. Okay, so that basic prerequisite knowledge is very much essential whenever we are trying to explore data visually in analytical workbench. Now, from comparison, first of all, I would like to begin with my research hypothesis. Our focus is on sales variable, right? Our target variable is sales. So I would like to study what is this sales progression. But sales is a simple data item. Our case study title is impact of demographics on sales. That's why you can start with either univariate analysis or bivariate. For univariate, you can discover the art with several possible visualizations ranging from a simple histogram to box plot and many others. And for bivariate, typically the combinations might go with bar chart, column chart, or if you are studying the relationship between 2 numerical variables, you can experiment with a scatter chart also, scatter plot also, right? So here we have the relationships here for bivariate. Parts to whole, we have the popular pie chart, the box plots and others. For comparison cases, we also have all these things. Additionally, Cognos also determines which type of visualization suits for what type of data automatically. To begin with, initially, I am choosing a column chart here. So all of you can click on the column chart under comparison category. So click on column chart. The rough skeleton of the column chart is in front of us. Now, what I'm trying to depict. Now, let's start our hypothesis. First one, do you still think participants' gender has an impact on sales? That's a question that we are debating. Initially, we had a benefit of doubt that gender might not affect sale, but after initial understanding of the data and some basic exploration, we could discover some interesting facts. To a certain extent, gender has some effect on sales. So let us discover that. So you can see here the external skeleton of building the column chart is available. You have the field section such as bars, length, and certain other parameters. So our intention here is to study the relationship between how gender is affecting the sales. On the left hand side, if you click on the sources, please notice the mouse movements carefully on screen. If you click on the sources, you will get the data set and the columns in the data set. All we need to do is drag and drop, that is rearrange our data to build the visualization. This is like pivoting, rearranging the data in order to build our visuals. So the interested variable that I'm going to study, that is our target variable sales. And the explanatory variable that I'm interested to visualize is gender. So drag gender variable with your mouse and drop it under bars area. Bars are nothing but categories. Essentially in a column or bar chart, bars section represent categories, qualitative data. So in our data set, gender is the one of the qualitative item, categorical. So I drag and drop in the bar section. Please do this action, participants, everybody. Drag and drop gender feature under the bar section. Similarly, you can drag and drop the quantitative variable or target variable sales into the length item. Length here means we are interested in studying the distribution of sales or dispersion of the sales. Typically, Cognos calls this as length under the bar and column. So make sure whenever you are trying to use the length parameter, definitely you should use a quantitative data item there. Quantitative item. It can be predictor or target also. So when I dragged the length column, could you all witness a typical column chart visualization is generated by our Cognos here? Would you all see that? Yes. Yeah, we need to further format this graph. You're right, Javji. The colorification format has to be more value addition. That's why to add more light to the graph, we would once again take the gender field and drop it into the color palette. If I drag the gender and drop it into the color section, where is color section available for you participants? You can scroll down vertically. When you scroll down, you can see other features offered by Cognos to make the visualization enriched more. So I drag the gender and drop it in color. Now you notice the color distinction here clearly, right? The color distinction is happening here. So this shows the relationship between gender over sales. Gender is on x-axis, sales is on y-axis for information. But what does this columns or bars correspond to? Typically, in any data analytics tool, the default aggregation is the sum function. I repeat, please note down. In any analytical tool in universe, if you take the default statistical aggregation is considered as the totals or the sum of that parameter. That is, this column graph is indicating that the total sales generated by the gender for the firm. So make sure all of you could get this graph for your information. Now tell me which gender is contributing to the sales greatly. If you hover that, you're getting a tooltip here. When you hover your mouse pointer, the tooltip pops up. You're right, Sarabji. Female sales attribute to 511K, while male sales 360K only. But individually, if you see each record in the data set, maximum sale was generated by a male salesperson, minimum sale was generated by, again, male. At this point, if I would like to ask you for a critical decision, if you are a sales manager of this company, which gender do you think is performing gender for sales? you had some insight from the data that maxima and minima were by male salesperson. After visualizing the pattern, we discovered total sales were better disposed by females than male. Zoebji would opine that as hires are female, as higher total sales by females are higher than males, Zoebji would like to go with female gender. Other participants, please share your insights on the chat quickly. If you are the sales manager, how would you assess the performance of sales team by gender? Sharatji also believes in total sales by female. Correct. Any others? Renuji, Satyamji? Very good. All of you would go by female gender. Great. This is one pattern that we depicted. Before we make any decision with data, the beauty of exploratory data analysis is we could discover multi-dimensional analysis first. We should not confine our thought, our analytical common sense only to one or two insights. Further, we have to explore the data top to bottom, depth and breadth. Now, to bring the real magic in the data, what we can do is in the current visualization, as you can see, as I already said, participant, the aggregation of the data is on totals, right? So to discover the magic, what you can do is navigate to the length column where we have positioned our target variable. Then click on more options. So see here, once again, navigate to the length option where you have put the sales target. Click on the more options or three ellipses button, dots, and in the drop down, could you see the summarize function? How I am depicting? In the summarize function, what is the default statistical function Cognos is preferring? Anybody notice that on screen? For the target variable, the default one is auto sum. You're right, Saurav Sharmaji. Thank you. Auto sum. That means Cognos is projecting the total sales by default, which says the story that female gender are driving total sales better than male. If you change this aggregate function to average, that means the data analyst is interested to study what is the average sales of the company by gender. So everybody go to the navigation again, click on sales in rupees, go to summarize, that is summary statistics we are studying on the data, and click average function here. And now you see the magic. When you change your statistical aggregation, average sales by male gender is found to be more than a female. But still they are closer participants, right? Average sales of male and female are not significantly different, but closer. But at outset, average sales of male were higher. Now at this point, if you are the sales manager of the company, two different insights are in front of you. One is total sales of female are higher than male, while average sales of male are higher than female. So how would you assess? Do you think gender is now somewhat a significant predictor in driving sales, participants? What is your answer now? Yeah, some of you might still have uncertainty. We can still say to certain extent or no extent or some extent, gender might drive sales. But at this point, we cannot answer the question, right? At this point, the researcher might not have a clear picture, crystal clear picture of how gender is affecting sales. Yeah, right. There are certain observations, psychological facts around why this is happening. What makes male gender go higher average sales when total sales by female were predominantly uncomparably higher? There are certain internal dependencies. Do you think, participants, to address this question, we need to explore further? What do you say all? To address the question of concern, what I was asking, how is this pattern reflecting? Do you think further we need to do more ED on this project? What are your recommendations? Obviously, we need to go deep inside the data for further insight management. All these visualizations, which we are now generating here, you could see in the exploration section, all these visuals are being added on the panel. So if you click on exploration, all the visuals are added to your panel. Finally, you can save that project as exploratory analysis. That is how you conduct. Now, I would give the opportunity for all our participants. Could you generate more visuals for me? I mean, discover. This is by gender versus sales. Likewise, could you show me some visual where you could study some pattern between location and sales? Please give a try, all of you. Please give a try and generate the insights. So to generate that, what you need to do, just go to the create button and click on visualization and choose a type. So I would like to see from our participants practice. Could you give more insights on how location is affecting sales? Location is a qualitative item, categorical. Sales is a numeric. Which type of graph do you think might suit to this exploration? Either you can go with column chart, bar chart, or even pie chart also. Why a pie chart can be more suitable here, anybody? Because three regions individually contribute to sales. All three together totally attribute to sales. Thus, if you want to study parts of data to whole data, suitable recommendation can be pie chart also. So our next methodical exploration can be a pie chart here. You can click on the pie chart, participants. So selection of visual is also crucial and critical in exploratory data analysis. People might go with alternatives to pie. There is no wrong or harm in it, but putting the right visualization for right data can give better insights and give better interpretability for observers. So I have chosen a pie chart, for instance, here. Unlike the bar and column, which have coordinate axis, pie doesn't have any axis here, but it has rather segments. Segments are nothing but categories. So the question of concern here is, we are hypothesizing that as part of a research problem, whether location is affecting sales. So which variable denotes location in our data set, participants? The beauty of Cognos tool here is you can see some preceding symbols associated with each variable, like a hash key depicting unique sequence of values, ABC label depicting text or strings, scale variable depicting numerical continuous variables, a geographical map bubble icon depicting some geographics. Okay. Yeah, right. Let's see how this works better. I am dragging the location field into the segments. I'm dragging the location field into segments and taking of my target variable sales into size. Size, like as length in bar graph or column, size is the numerical measure in our pie graph. Now, quickly Cognos generated a pie graph for me. Please check, participants, could you get a similar pie graph on your screen? If you're doing a bar or column, that's up to you. Or alternatively, if you're trying pie graph with me, yes, thank you, Satyam Soniji. This is a pie graph. What does pie graph represent? Propositions, compositions of each data item to the whole data. Our total sales were 871. When we run the analytical query with virtual assistant, we could see 871K, out of which Hyderabad's contribution is 466K. You can see the legend color, the red color Hyderabad. The green one corresponds to the Mumbai here, and the 224 corresponds. By hovering the mouse, you get the readable tooltips also automatically. The tooltips. So which region generated more sales for the company, participants? Comment on this in the chat. Out of the given three regions, it is evident that Hyderabad region could generate better sale. So it is clear. And which region generated minimum sale out of the three regions? Correct. Mumbai could generate less sale. But any other interesting patterns that you could share to me here? Let me see. Bangalore neither generated maxima nor generated minima. Please take a look at Bangalore region sales, 224K. Neither generated maxima nor minima. In terms of total sales, I'm talking about, not individual sale. But individually from salesperson's perspective, like what we saw in raw data, which region witnessed the maximum sale per salesperson, if I ask you? That is, as per individual salesperson performance, which region? Very good, Zoebji, for remembering that point. Bangalore, correct. But overall performance of salesperson at Bangalore, is it maxima? No. That's why data exhibits uncertainty, veracity, and biasedness. Such a highly very biased and uncertain data, do you think should be put forward for analytical modeling or not? Obviously. That's why the current world of research is now transiting, moving from a simple statistical research to a more robust, complex, sophisticated, scalable analytical research. But statistics still becomes the foundation for data analytics also. That's why coming days of research in academia and industry should focus our efforts on moving to the analytical implementations in research. Thus, Bangalore could not do. But another interesting point for all of you, sum up the total sales of Mumbai and Bangalore together, anybody? And please share the total, ladies and gentlemen. Add the total sales of Mumbai, that is 181, and Bangalore 224, and tell me the total value. 181 plus 224, which would come around how much? 405. Thank you, Zavji. Other participants also try to be interactive with your answers in the chat for a better learning. 405. Thank you, Riyaji also. 405, do you think is less than 466? Thank you, Ranu Saji. Everybody, correct. Compare. Yes, less. That means what interpretation could you draw from this pie chart, participants? Anybody? Collectively, Bangalore and Mumbai together could not achieve a sales which Hyderabad alone could achieve. I repeat, collectively, how the interpretation should be written? Hyderabad alone is far driving sales when compared to Bangalore and Mumbai together. See, these are all the rich insights that we are producing using exploration and visualizations. Right, correct. Now, at this point, if I would like to ask you, if you are the sales manager of this system, would you like to continue the provinces of Mumbai and Bangalore in future, or would you like to confine to Hyderabad only? Because Hyderabad alone is significantly driving sales. So what is your opinion? Would you like to continue all three regions? If so, type 3 as answer in the chat. Or would you like to only go ahead with only one region in Hyderabad? Zoebji opines, one should try more regions, right? Yes, because several parameters might affect. But Ranuji has a different opinion, discontinue with Mumbai, right? Ranuji, what made you choose the option discontinue Mumbai? Maybe the total sales of Mumbai are quite low, uncomparable to the remaining two. Maybe due to that reason, we could believe that discontinue Mumbai. But as an exploratory data analyst, all participants, this is question for you. Do you want to go deep inside the data and further discover why Hyderabad region got more sale comparatively to Mumbai and Bangalore? Do you think we should explore that also before deciding whether I should discontinue Mumbai or not, or whether I should confine to Hyderabad only or not for future? What made Hyderabad become the winner and Bangalore and Mumbai fall behind the race? Obviously, that is also required. That's why before we make any critical decision for our business, all data-driven exploration in depth should be done. You're right, Sharadji. More and more exploration should be done. Now, the next part is, because we are now currently in the location, what made the sales at Hyderabad go higher? Let's create one more visualization as value added before I proceed to the basics of data pre-processing. Permit me, participants, can I take one extra session on exploration and visualization on the Monday session also with your consents? Yes, because this is a huge activity which cannot be completed in 2 hours if you want to understand the top to bottom. Correct. So at the outline, I would reserve the remaining minutes in this session more for exploration and basics of pre-processing, but more pre-processing insights. I would continue the session on Monday alongside with the dashboard session also. Right. Thank you all for your consents and consent for active participation. Great. So now I would like to proceed choosing a type of visualization here, because at this juncture, we are still in an uncertainty, lot of uncertainty. Why Hyderabad witnessed better sales? Why the remaining two are lagging behind, right? Great. To address this question, let me start with a comparison chart. For instance, I again choose a column chart. So let's start with the core again, column chart. We are interested to study column or bar. Most are similar in representation, vertical and horizontal. I would like to study the location as my category bars and my target variable sales in rupees as the length here. Right, sales in rupees as length. Or typically, already we discovered this, so I don't want to go around here. I would like to see how the gender are differentiating. Let me focus on gender also. So how I would start is the distribution of salesperson by location. The next important query that we are going to discover is how gender of salesperson are distributed physically at different locations. So we would go ahead with the gender here initially. We can customize these graphs as per our convenience. Location, I would take into length here. And the target variable, I would like to take it as again gender. I will drag the gender into this thing. I would see here there is some graph which couldn't generate much pattern, much meaning, so I can customize it here. So my primary focus would be on location here. Location I'll take into bars. Location I drag and drop it in bar section. Gender I will take into length. I will later aggregate it. So you can see here the graph is being now produced between what? Location and gender count. Are you getting my point, participants, everybody? Rather than addressing the target variable always, sometimes it is a good practice to study the relationship between predictors also, because analytics always deals with study of examination between predictors to target, but a good data analyst also focuses on assessing the relations between internal predictors also to study the correlations or multi-collinearity. So I have chosen location into bars, gender into this thing, that is distribution. On this gender, you could see Bangalore, Hyderabad and Mumbai seems to be equal until I try to change my summary function. So I'll change my summary function to count. Now, could you see the distribution of salesperson over the locations? Of course, this is not by gender. This is simply distribution of salesperson by location I'm drawing. I didn't customize it by gender yet. Now, if you could see how many salesperson are working at Hyderabad location, anybody? Check out in the graph. We are trying to project the count of salesperson by location initially. So 8 salesperson. You're right, Georgie. The column graph says on the y-axis that the y-axis is the frequency count of the gender or distribution of the salesperson, and the x-axis is location. Hyderabad has more salesperson in number. 8 salesperson are working at Hyderabad, while at Bangalore and Mumbai, how many are working each? Check out. At Bangalore and Mumbai, how many are working? 6 each. Very nice answer, Georgie. Look at the y-axis, participants. Or if you can move your mouse pointer, you get the tooltip. 6 each. Now, don't you think this might be one of the causal effect why Hyderabad could have generated more sales? What do you say? Come on, extend your research hypothesis step by step. Because of availability of more salesperson operating at Hyderabad location, there is a high probability that sales can go higher. Correct. Sales can go higher. Typically, psychologically saying, because of the less number of salesperson operating at Mumbai and Bangalore, there is a probability that the decline in sales might have. How many of you believe in this hypothesis? Psychologically speaking, more number of salesperson contribute to better sale. Less number of salesperson might contribute to less sale. Can it be a believable hypothesis? It can be a suspectable hypothesis. Yes, Ranuji says it can be one of the reasons. But is there also other probability? Think out of the box, participants, analytically. Even with less salesperson also, is there a chance that sales can go higher if all the salesperson are working hard? If only numbers matter, then definitely results also matter. Who knows, maybe coming down the line with 6 salesperson, can Bangalore and Mumbai overtake the total sales of Hyderabad? Even if 8 salesperson are working there, can there be a chance? Exactly. That's why distribution of the data gives an insight, but not a decision, I say. This visualization is allowing us to discover why Hyderabad got higher sale. You should work like a detective, investigator here, I say. Maybe the chance of more salesperson, maybe the probable word I'm using, but there is no belief in that hypothesis that The number contributes to the sales. But again, here, if you see Hyderabad, to distinguish here, I could actually put the location in the color attribute for your distinction. Drag the location and you could see the clear picture here. This distinguishes better than the previous one. Location has more. Hyderabad has 8 people count working. But do you think, participants, based on the gender, further we have to disseminate our data? Who are those 8? Is it all males at Hyderabad? Is it all females at Hyderabad? Or is it the composition of male and female put together at Hyderabad who are driving sales? Do you think we should explore that pattern also? What do you say, participants? At the outset, we discovered a high level insight that Hyderabad has more employees. But among those more 8, we also should go on the basis of other parameters. Yes, Ranuji says you can analysis on the basis of age also. You are right. Let me show that also here. So I will keep this visualization currently. Now let us go for age also. Yes. So let's add one more visual to our exploratory analysis, participants. Choose a type. Every time to add, you can click on create, select the card and choose a type. Now, because age, what type of variable is age? Is it a categorical variable or continuous variable? Age is a numeric data item, so it is a continuous variable, right? Similarly, our target variable sales, it is also continuous variable. Thus, from the knowledge of choosing data visualization schemes, which is a prerequisite in analytics, which graph type do you think is more appropriate to study the relationship between 2 continuous variables? Scatter plot. Please take a note of it. Scatter. Great. You're right, Saurabhji. Why we have chosen scatter plot? Typically because the power of scatter visualization, it not only depicts the pattern, but it explains the amount of correlation and linearity also. I repeat, the reason behind choosing scatter plot to do a bivariate analysis between 2 continuous variables is the observer or researcher can study the internal correlations among the continuous variables and also depict the amount of linearity or non-linearity present in that data pattern. That's why we now move to the relationship section in Cognos and try to choose a scatter plot here. Now we have the scatter plot in place, and all we need to do is we need to choose the right parameters for our access. So what I do is I am interested to show the ages of the salesperson on x-axis, sales generated on y-axis. Request all the participants to operate the scatter chart accordingly. X-axis is age, y-axis is sales. You get a single scatter dot depicting the total or average sales. This is the average age and average total sales here. But to generate a pattern to determine the correlations, again drag the target variable. You can again drag the target variable, which is sales in rupees, to show those sales as point projections on the scatter. I repeat, x-axis is already age, y-axis is already sales. To show the correlation pattern as scattered bubble dots, you choose your target variable as the point projection distribution. So drag the sales in rupees into the point section, participants. Now you get a scatter plot. You can get a scatter plot. Could all of you get this scatter visualization generated? Please confirm, participants, everybody. Yes, thank you. Now, how to interpret this scatter plot? See, x-axis depicts age of salesperson individual, y-axis is sales in thousands. A 19-year salesperson generated around over 35K. A 20-year salesperson generated a minimum sale 11K. Likewise, as ages are increasing on x-axis, what is happening to the sales on y-axis? Anybody? See the graph and type your interpretations in the chat. As age of the salesperson is increasing over years, do you find an increasing? Mamataji says that she could find an increasing pattern over ages. Great. What about our other participants? What are your answers? Yes, there is some varying pattern, but the range is not that linear. You're right, Mamataji, again. Thanks for adding that point. There is not a definite linear pattern. Now, my question to all the participants is there a certain linear pattern found? What is meant linear? As age is increasing, so is sales increasing. Is such a pattern there in our problem? No. That's why the relationship between age and sales is highly non-linear. That is the interpretation we have to draw from this scatter plot. You're right, Riyaji, everybody. There is a non-linear relationship between this. But if you see at the age of 24, how many data points are there? If you see here, there are around 6 salesperson who are of the age 24 years. The number of dots represent the count frequency. In the company, out of 20 salesperson, around 6 people are at the age group of 24. So 6 out of 20 is a good number, but is that age contributing to better sales? Again, out of 6, 3 salesperson of 24 year, what is the contribution to the sales? Anybody? They are between 25 to 30K only. So what is the use of having those 24-year salesperson in the company? Is it a critical thinking or not? What do you say, Vishalji, everybody? Yes, 24-year salesperson are more in number, but their contributions, 50% of them are within 25 to 30, while remaining are at the median 40, or 2 or 1 of them are critical, better performing. Likewise, when we further move along the x-axis, participants, the higher the age, what is happening to the sales? As age of the salesperson is increasing slowly above 24, what pattern do you find in sales? Is it increasing or declining? To certain extent, it is increasing. That is, a 25-year age salesperson, a 26-year salesperson are of course in the better sales horizon than 24 and younger. That means younger aged salesperson pattern shows a very least sale, while a middle-aged person, 24 to 25 to 26, which you can consider as middle age, are driving better sales. Now, if you further go higher, look at the 27-year, 28, 29, 30, as age of the salesperson is increasing, the data depicts the pattern that the sales are declining. So this is the analytical trend that we could discover. Imagine if we didn't do this kind of analytics on data and we go with our psychology. Age, an elderly age person might have more experience, obviously, can drive some sale. Younger age person might not have any experience except energy, might drive. But for this company, which age person are driving better sales as per this scatter plot? Anybody? Is it younger age individual, elder age individual, or middle age? You're right, Mamata Samalji. It is the middle-aged salesperson who are driving prominent sales for the company. How can this pattern be useful to the sales manager or HR manager in the company? Do you think this pattern can help them in future decision making regarding recruitment of the salesperson by age? What do you say? Obviously, to a certain extent, now the resource manager who is hiring the salesperson will get some knowledge inclination synthesis that better focus on age of the individual when recruiting. Correct. Age 27 has 2 probabilities. One is either too high sale. You're right, Ranuji. Nice point you brought up. Either too high sale or least or moderate. Can that age be a risky individual, Ranuji, according to you? If you are the sales manager or HR, do you consider focusing on a 27-year can be a risky profile when recruiting for the firm? Correct. That's why analytical explorations of the data give a lot rich insights. That's why. Now, if I ask a question, should now the businesses, organizations of the 21st century in the technology era should be data-driven decision-making companies or not? Yes, undoubtedly, all the organizations should learn the art and science of business intelligence and data analytics and should go for data-driven decision-making. When already industry is in data-driven decision process, would you recommend your academic institutions, research universities, and colleges also to be plunging into data analytics and data-driven decision research in the present and future? That's why incorporating analytical insights practices into the learning curriculum is a definite edge for better knowledge management, I say. Correct. Great. I hope everybody is able to grasp the essence of the case study so far, both conceptual and analytical experiment also. Now we can add more insights. I mean, you can drill down the data further to the extent possible. So we discovered how gender is affecting sale, location is also affecting sale, age of the individual is also driving. Thus, our case study title, research title says, analyzing the impact of demographics is a very important concern for research modeling through application of data analytics, I say. Even too, you can scale this analytics further by adding more rich insights as I was debating on location versus the sales. So once again, if I choose a location on my bars, gender as my length, right, that would obviously give me some projections here. Yeah, yes, you're extremely right, Mamata ji. Is it technology the driving force of the organization, or is it the data the pivotal element? Mamata ji has already answered her opinion in the chat as data is the most important factor. Undoubtedly, technology is no different from magic, but data is the pivotal element, does the real magic when coupled with information technology, I say. So those organizations who are unleashing the potential value of the data, unlocking the power of IT, are the superior sustainable organizations of today and tomorrow, I say confidently. Correct. Now, the next experiment we are going to do in exploration finally is discover how location can, coupled with gender, can give us more insights. You are right, Sharadji. Data is the most pivotal element from this observation. Now, I would like to customize my summary on distinction of gender here. So the same experiment that I carried out so far, I'm doing it more value added. All participants are requested to do this final aspect. Pull your location on bar section, gender on the length section, and change your summary statistics to count function. This shows distribution of the person by the location here. Then I would like also to add some more insights into it, the filter. Alternatively, as like in most analytics tools, you can also restrict the data patterns by filtering them. How to filter? You can just click on your required data parameter that you're interested to filter. You have certain options like sorting the data, filtering the data, or formatting further for better enrichment. This time I'm choosing the filter option. I'm not interested in all the three locations. Mumbai so far is falling behind the race. So at this point, I might keep Mumbai region away from analysis, opining that Mumbai is falling behind the race. So I choose only Hyderabad region and Bangalore region. So how I'm choosing? Selecting the filter option and trying to filter my visualizations. Then choose done. Now this visualization turns get filter to study the relationship between only Bangalore and Hyderabad. Then we can also focus more on this thing. Drag the gender into the target variable again. Gender into the target and location into the color code. Now you could see here the distinction is being made by gender. If you want, you can add gender also into the color. More drill down of the data I'm trying to do here. More drill down of the data. Now you could see here, this is the dispersion of the data by gender and location. At Bangalore location, if you see the composition of sales by male and female, look at the color composition. At Bangalore, the contribution to sales by male and female, aren't they closer or not? Right. You can customize the visualization in much better way also. Right. You can break down. This is called slicing and dicing the data in analytics. Drill down, drill up the data in analytics. At Bangalore, do you find any significant difference in sales by gender? What is your comment on this question, participants? There is not much difference in sales progression at Bangalore by gender. But what about Hyderabad? You're right, Ritika Pandeyji. There is no difference at Bangalore. But what about Hyderabad, Saravji? All participants, kindly. Yes, Mamataji finds some difference at Hyderabad. That is, which gender is doing better at Hyderabad? Already you know that at Hyderabad, what is the total count of salesperson? 8 salesperson are there. Correct. Yeah, we are not putting any sales here, but you can drill down, Zabji. You can also put target as sales. Actually, for your distinction, I just put gender. But if you want, you can put sales also. That also we can add here. Typically, the count of females are 5 at Hyderabad and 3 at males at Hyderabad. I can say 3 males are working at Hyderabad, 5 females are working at Hyderabad. So out of it, more females are at Hyderabad. To drill down the pattern as requested by participant, we can add the sales segment also here. Let's add the sales segment for more knowledge insight. So what I do is in my target column, I will drag the sales and deposit in my target. Right, this is the target. Let me remove the gender for customization. And here, I would like to summarize by the count. You can further customize here, or if you can just remove the filter by choosing all 3 locations here again to bring back the chart to its original. So to do it from the scratch, I say, you can remove the filters. You can uncheck all the filters here. Or I can typically remove this column, begin from scratch. So each insight has some value. So first we need to position our elements, how we want to drill down the data. Location I want to discover on bars. Length is the sales in rupees also. You want to see the sales in rupees, Zabji, as you are trying to discover the impact of correlation between this thing. Gender, I can put it in my target also. You can customize these things. So here on gender, I would like to summarize by count. I can show it by count here, right? And length also you can summarize, or else I can swap these 2 fields. I can just bring sales into target initially. Right. Location in bars, target in sales, gender in length. Now there are some notches coming down here. So you could see here the gender distinction and sales here. Gender, if I want, I can put it in color also. I could see here female and male color distinction, a complex graph, but you need, why the graph has become more complex is we have chosen a column graph here. But when you want to show multiple composition of data items, do you think understanding this graph is such easy, participants, or we need to change the type of graph? We need to change essentially the type of graph. That's why for such kind of analysis, we can go working rather than a column chart. I would like to go for a stacked column, right? Stacked column would be the best option here. So I would change my visualization type because the visual patterns seem to be seamlessly complex on column. I would rather change transit to a stacked column, or you can choose stacked bar. So here you can put here location in bars, the gender into our length column here, and sales in rupees into our target or any other parameter in color format. Then gender, I would like to just summarize by count here. Now, what do you see here? The pattern is now changing. Location is on x-axis, gender is on y-axis, and the distribution of sales is shown on a scale. The darker shade depicts which sale. The darker one depicts the maximum intense sales. Lighter ones are minimal sales. Then you can also further drill down this data by projecting the gender into the color column also. Further, you can refine the customize. Now you could see some stacked bar coming. Distribution coming by gender and location and the value. Hyderabad has the more specification of distribution of sales by gender. You can see female. Who dominates the maximum sale at Hyderabad, participant? Look at the color code, a female, right? A female is generating better sale at Hyderabad, right? So you can customize. I'll add more value in the coming session by disseminating different type of complicated graphs also. So this is a know-how in depth about the exploratory data analysis through statistical visual practices on Cognos. We are yet to do of data pre-processing as discussed. We will be discussing on the need for data pre-processing, when and where this pre-processing is required into play. Before I conclude, I would request all our participants also to apply your practices on EDA discussion session today on other data set that we gave for you, that is bike buyer 1. Already, I think most of you have uploaded bike buyer 1.csv dataset into Cognos accounts yesterday. Please try to give a try on applying all the discussions done so far today on a simple sales dataset on more complex bike buyer from your side on EDA. But one challenge that you all should discover, that is something unusual in the dataset which we gave to you intentionally. Unlike the sales dataset, which is crystal clear, complete 100%, there is something surprises in the dataset that you would discover by practice in the weekend session and bring to our light in the next session on Monday evening, what peculiarities you find in the data after EDA. That will become our initiation point, why we need to go to data pre-processing after exploratory data analysis in analytical framework. Ranuji, you can have multi-dimensional visualizations also. When we go for bubble chart, when we go for tree map visualizations, they are much more robust visualization than simple bar and scatter. When we want to go multi-dimensional, preferred charts include tree map or heat map or other type of visualization like bubble charts also. Yeah. That's all for this session of time. Shivam, you can now open the floor for question and answer on EDA.
Yeah. So thank you very much, sir, for delivering the wonderful session. I hope all the faculties are very clear with today's session, and I hope everyone doing hands-on parallelly with sir.
Sure.
Now I request to all the faculties, if you have any questions, we are open for Q&A. And one more announcement, I shared one feedback form regarding the last 3 days session. So I request you all to please fill the feedback form. We shared in the WhatsApp group as well as in the Zoom chat. So dear participants, now we are open for Q&A. I request you all to please post your queries, or you can unmute yourself to ask the questions.
Sir, these graphs can it be somewhere in the image?
Yeah. This can be, see, that's what I was telling. If you can see the application, all these graphs can be saved, sir. Can you see the save button here? Yeah. If you can just see, you can save this, all the exploratory analysis into one project. All this can be saved here. So you can name this exploratory analysis some project. I just call it as sales EDA, and by default you can save them on my content folder, and you can save them also. Whatever activity that we carried so far, all the project activity can be saved to the Cognos my content repository for future reference also. Alternatively, you can pin. So if you just click on the explorations, you can pin. You can see the pin button here. Current visualizations can be pinned out. Whichever visualization you want, you can pin them and transfer them to your required dashboard, report, or story point also, wherever you can use it. And probably such items can also be shared. You can click on the share button and create a shareable object resource link, external link, or email them completely also, or different platforms.
Yes, I think share with
Yeah, you can share also. Your voice is quite low, sir. Whoever is speaking, your
Sir,
volume is.
I'm saying that whether it can be saved like an image or not.
Can you please type the question if you don't mind in the chat? You are breaking the voice in between. Yes, please type it, sir. Yeah, image format. See, yes, you can export these graphs. Joebji, you can export. Cognos already has inbuilt facilities for you to export or transfer these visualizations, parts of the visualizations as a whole into a dashboard, or individual elements into different report formats. You can still download. There is a download option available in dashboards for you. when we move to the dashboards, there is a download option. As an entire dashboard homogeneous visualization or individual parts also, you can download them. Sir. Hope you are clear. Yeah. Right. Any other questions, participants? Let me know. Any other questions on the discussions done so far? Hope all of you could get the real-time experience exposure on how critical is EDA for real-time data. We would expect the participants to continue the learning journey with your practices. So you can try it on the other data set or other open source repository data sets that you can procure from available repository like Kaggle, UCI machine learning. I would recommend at the outset before concluding session, all faculty could please visit. I'm just sharing it here to everyone in the chat window. Please visit the websites of the government repository data.gov.in. Please check my chat to everyone. Try to procure much of the real world data assets from this website data.gov.in across diverse verticals related to agri-science, marketing research, financial analytics, or supply chain problem statements, real estate, or any other kind of industry business verticals are all available publicly. Openly published data sets are available for more industrial real-time research experiences. You try to, each one of you in a free time could are advised to explore these open repository, which would add more value to your Cognos analytics experiences. And there are many multiple that of course we will disclose on the last day of the discussion. Any other questions? Let me know. So thanks a ton to all the participants for your patient listening on day 3 of the FDP and following the on-screen analytical implementations. Thank you to all the ladies and gentlemen for this evening weekend session. Happy weekend. Thank you. Signing off. Over to you, Shivam.
Thank you very much, sir. And thanks to all the faculties to listen the entire session. And we have another session on Monday. So I request you all, whatever the activities assigned by sir, please complete that. And we have a session on Monday at the same time, 6 to 8 p.m. So thank you to all the faculties and thank you, sir.
Thank you.
Thanks.
Thank you.
Now we are going to sign off. Thank you.